Assalamu alaikum. Welcome to my YouTube channel. And continuing from the last video, the fourth number is Grace number. Grace number is equal to the heat transfer by convection to the heat transfer by conduction into D divided by L. Mathematically, it is equal to D divided by L into Reynolds number into Prandtl number. So the second form of Grace number is Peclet number into D by DL. As we know, Reynolds into Prandtl is equal to Peclet number. In the formula, D is the hydraulic diameter of the tubes and L is the characteristic length. Grace number characterizes the laminar flow in a conduit or a channel. It is used to analyze the heat flow in a pipe, and if we have a Grace number greater than less than 1000 or equal to 1000, then we call it thermally dominant or thermally developed, fully developed flow. So in mass transfer, we replace Prandtl number by Schmidt number in the Grace number formula, and the formula becomes Grace number is equal to D upon L into Reynolds number into Schmidt number instead of Prandtl number. So if someone asks you that what number is used instead of Prandtl number, or what number is equivalent to Prandtl number in mass transfer, then the answer is Schmidt number. So another form of Grace number is U into D square divided by Kx, whereas U is the velocity of the fluid, D the diameter of the pipe, K the fluid thermal diffusivity, and X is the axial distance along the pipe. So this number, Grace number, represents the ratio of the time that is taken by heat to diffuse radially into the fluid by conduction. So it is the ratio of the time taken by heat to diffuse into the fluid by means of conduction transfer. So the inverse of Grace number is the entrance effect of laminar flow in a pipe. So when we have Grace number that is equal to 1000 or less than 1000, then we call the flow as thermally fully developed flow. At number 5, we have standard number. Standard number is the ratio of wall heat transfer divided by heat transfer by convection, and it is mostly used in forced convection heat transfer calculations. Mathematically, if we talk about heat transfer, then standard number is equal to Nusselt number divided by Peclet number, or Nusselt number divided by multiplication of Prandtl number and Reynolds number. And it is also equal to H divided by Cp into rho into V. Rho is the density and V is the velocity. Another form in heat transfer for standard number is H upon Cp into G, where G is the mass velocity. If we talk about mass transfer, then standard number is equal to Sherwood number divided by Reynolds number into Schmidt number, or standard number is equal to beta divided by U, where beta is mass transfer coefficient. From these formulas, you can conclude that Sherwood number is equivalent to Nusselt number in heat transfer, and Schmidt number is equivalent to Prandtl number in mass transfer. So this is very much important for your job related tests, and you can conclude these points. You can note these points in your notebook when you are going through these slides. Now, importance of standard number. It is important, very much important, and it is used in Reynolds analogy. In Reynolds analogy, we use a particular thing which is called CF. CF is the skin friction coefficient or skin factor. So in the Reynolds analogy, if we have Prandtl number that is equal to 1, then the standard number will be equal to CF divided by 2, or we can say that standard number into Prandtl number power 2 divided by 3 will be equal to CF divided by 2 in Reynolds-Colburn analogy. So this is very important relation, mathematical relation, in order to calculate the skin friction factor and standard number. Then finally we can also calculate heat transfer coefficient if we know standard number, because If we know standard number, we can calculate Nusselt number, and if we know Nusselt number, we can calculate easily the heat transfer coefficient. So this important ratio you must keep it in mind in your notebook, because it is also asked in many different tests. Now number 6 is Grashof number, GR. It is the ratio of buoyant forces to viscous forces, and mathematically it is equal to G into beta. In bracket we have Ts minus T infinity bracket over, then L cubed whole divided by V square. Here G is the gravitational acceleration, beta is the coefficient of thermal expansion, Ts is surface temperature, T infinity is bulk temperature, L is the vertical length, V is the kinematic viscosity, and V is the kinematic viscosity, and the formula for kinematic viscosity is dynamic viscosity divided by density. So when an object in a fluid is placed, then the fluid exerts an upward force. That upward force, we call it buoyant force. So you must keep in mind that what buoyant force is. It is an upward force that is exerted by a fluid. So if we have a Grashof number greater than 1, then it indicates that the viscous forces are negligible and the buoyant forces are dominant. Now coming to the significance of Grashof number. Grashof number is used to check the fluid flow behavior around a new prototype, and it is used when buoyancy and viscous forces are considered as important. So this number shows how dominant is the buoyancy force with respect to the viscous force according to its value. Now Grashof number is very similar to Reynolds number. The difference is that the Reynolds number is used in the forced convection calculations, while the Grashof number is used for the natural convection phenomena. And Nusselt number, we know that it is a function of what? Prandtl number and Grashof number. So in this slide you have very important information to be noted, which is that Grashof number is what? The ratio of buoyancy forces to viscous forces, and Nusselt number is a function of Prandtl number and Grashof number. Please keep it in your notebooks. And Reynolds number shows the flow as laminar, transient, and turbulent, while the Grashof number does the same in natural convection. So if we talk about natural convection, then we talk about Grashof number, while if we talk about forced convection, then we talk about Reynolds number. Now Grashof number is a function of buoyancy force, inertial force, and viscous forces, and it is analogous to Reynolds number. At number 7 we have Fourier number, FO. Fourier number is a dimensionless number which is derived from the non-dimensionalization of the Fourier's law of heat conduction equation. It is the ratio of rate of heat transfer across in a volume divided by rate of heat transfer storage in a volume, or it is equal to diffusive transfer rate upon the storage rate. Mathematically, in heat transfer, Fourier number is equal to alpha T divided by R square, while in mass transfer, Fourier number is equal to D into T divided by L square. Whereas here alpha is the thermal diffusivity, T is the characteristic time, L is the characteristic length, T is the hydraulic diameter, and R is the radius. Now Fourier number is the ratio of diffusive or conductive transfer to the quantity storage rate. So if we talk about heat transfer, then the quantity is the thermal energy, and in mass transfer it is the matter particles. The number is derived from the non-dimensionalization of the Fourier's law or fixed law of heat conduction, and this number, Fourier number, is used along with Biot number to analyze the time-dependent transport phenomena. Please keep this point in mind. And this number is widely used in the prediction of the temperature response of materials undergoing transient conductive heating or cooling. When some material is going conduction, heating, or cooling in a transient phenomena, transient process, then the temperature response or temperature change is calculated by the help of Fourier number. Fourier number is used to characterize the transient heat conduction, and a larger value of this number predicts or indicates faster propagation of heat through a body, while a lower number will indicate the slower propagation of heat through that body. If we double the time, then the Fourier number will also be doubled, because Fourier number is directly proportional to the time. So kindly subscribe my channel and suggest me for more videos on this topic, because or on chemical engineering, and I am ready to make different videos according to your choice and your needs for your chemical engineering job preparations or exams preparations or your chemical engineering related studies. Thank you. Subscribe this channel, like, share and comment for appreciation, encouragement and suggestion. Stay united, chemical engineers.